Hey guys, Travis Gillespie here. We've been looking at sequences and finding patterns in tables and using those patterns to find the missing value inside of a table. So now we're going to take it one step further from here. So I'm looking at two people here. I have Sam's age and Grace's age, and I have some data that I'm going to write down in just a little bit. So it looks like when Sam was 2 years old, when Sam was 2, Grace was 6. And when Sam was 3, Grace was 7. And when Sam was 4, well, Grace was 8. So far, looking at this table, it looks like Grace is 4 years older than Sam. But I'm going to plug a new value down in this empty cell for Sam's age. I want to know how old Grace will be when Sam is A years old. Now that sounds a little bit odd, but I'm using a variable in place of Sam's age. Logically, you might think, hey, since we've been moving up in increments of 1 year at a time, so from 2 to 3 to 4, the next value should be 5. You might think that. But I'm not necessarily interested in finding out how old Grace is when Sam is 5 years old. So I'm going to undo the 5. The 5 doesn't necessarily have to go there. I'm more interested in finding out how old Grace is with whatever value I plug into Sam's this empty cell. So finding out how old Grace is when Sam is, I'm going to call it 8 years old right now. Another way of thinking of it is, how old is Grace with whatever value is in this variable? Okay, so let's see if there is a pattern inside of this table here. So what I want to do, I'm going to change pen colors, and we're going to break this table up into two parts using some words we're already familiar with. I'm going to think of Sam's age as the first set of values that are given to me. So I'm going to think of those as the term. In the second column, I'm going to think of Grace's age as the value. So if there is a pattern here, well, we can build an expression, an algebraic expression. So I'm going to write that down. If there is a pattern, we can build an expression. And we can use this expression to find out any value when given a specific term. So we can find out any age that Grace will be based off of the value that we've been given for Sam's age. Okay, so in order to do this, you've got to get really good at looking for patterns, and we're going to start with the value. So is there a pattern in Grace's age from moving from 6 to 7, and does that pattern hold true when moving from 7 to 8, and so on? Well, I see that, hey, this is moving in increments. It's moving up in increments of 1, so we're adding 1 pretty much. Another way of thinking about this is I have positive 1 over here. So I'm going to just take this value 1. Let me just change colors real quick. And I'm going to take 1 and multiply it by my term. And my term in this case, well, the term is 2. Okay, so 1 times 2. So I have 1 times 2. And 1 times 2, well, that's equal to 2. I'm just going to leave that there. And I'm going to ask myself, how do I get from 2 over to 6? So using that arrow again, how do I get from this value 2 over to 6? Well, I have to add 4 to get to 6. So I have 1 times 2 plus 4 will get me the value 6. Let's see if there's a pattern in this expression here. So I'm going to move down the line to the next value, which is 3. So I'm going to start with 1, multiply 1 times 3. So let's write that down real quick. So I have 1 times 3. And 1 times 3 will give me a value of 3. And how do I get from 3 over to 7? I've got to add 4 again. So 3 plus 4 will get me to 7. So again, I'm adding 4. Let's move on down again. You might see the pattern now and be able to figure out the rest. So starting at 1, so I have 1 times 4. So let's write that down. 1 times 4. And that's 4. So how do we get from 4 to 8? I have to add 4 again. So 1 times 4 is 4, plus 4 will get me to 8. So this last one looks to be a little bit tricky though. So I'm just going to draw one more arrow down. So 1 times, now be real careful here, because a lot of people are going to say, you know what you have to do? They're going to say you have to take 1 and multiply it by the value 5, because look, if you look through this table, we've moved up in increments of 1. So 2 to 3 to 4. The next logical answer would be 5. But 5 is not the value in this box, so I've got to get rid of 5 and use the value that's in this cell here. So I have 1 times A. So we have 1 times A. Well, 1 times A, it's simply equal to A. All right, so what do I have to do to A to get to this unknown value over here? I'm going to get my green pen real quick. Well, so far we've been adding 4 every time. Plus 4, plus 4, plus 4. The pattern's holding true. It's not changing, so I'm going to add 4 again. So I have 1 times A plus 4. Now I have an expression here. It's 1 times A plus 4, but I want to simplify it. So before we fill this information into this empty cell, let's think about how we can simplify this expression. In order to do this, just ask yourself, what is 1 times any number? Well, 1 times any number is that number itself. So 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, and 1 times A, it's simply A. So the expression that I'm going to fill into the cell, it's simply going to be A plus 4. A plus 4. And you can actually check this work. So let's try this out, and I'm going to check it real quick. And I'm going to use the value 4. I'm going to substitute it in for A. And the reason I'm doing that is we should get the value 8 as our final answer. So we have 1 times 4. That's the value that's been substituted in for A. Plus 4. Well, 1 times 4, that will give a value of 4. And if I add 4 and 4 together, I'll get 8 as my final answer, which matches up. So the expression holds true. Cool stuff. I'll see you in another video.